So let me first introduce some of our panelists briefly, and then the panelists would be making their opening remarks for roughly 15 minutes each. So we already have introduced Duncan Watts, and the panelists are Professor David Kotz, Professor Denise Anthony, and Professor Eugene Santos. Professor Kotz is a professor of computer science and associate dean of the faculty for the sciences at Dartmouth. He has spent the last year as a visiting professor at the Indian Institute of Science in Bangalore, India, and was a Fulbright research scholar to India. He has been the executive director of the Institute for Security Technology Studies from 2004 to 2007. His research interests include security and privacy, pervasive computing for healthcare, and wireless networks. He received his AB in computer science and physics from Dartmouth in 1986, and his PhD from Duke University in 91. Professor Denise Anthony is associate professor and chair in the Department of Sociology at Dartmouth College. She is also research director of the Institute for Security, Technology, and Society at Dartmouth, and a faculty affiliate at the Center for Health Policy Research at the Dartmouth Institute for Health Policy and Clinical Practice. Her research interests include collective action and trust, economic sociology, and sociology of healthcare. She has received her PhD in sociology from University of Connecticut in 1997, and she has done her postdoctoral scholarship at University of Michigan before joining Dartmouth. Fourth panelist is Professor Eugene Santos, who is actually a professor at Thayer. He received his Bachelor of Science in Mathematics and Computer Science from Youngstown State University, and an MS in Mathematics from Youngstown State University, as well as Masters of Science and PhD degrees in Computer Science from Brown University. His main research interests include artificial intelligence or AI, intent inferencing, social and cultural modeling, computational social science, automated reasoning, decision science, adversarial reasoning, and natural language processing, and a few more. He is the editor-in-chief of the IEEE transaction on Systems, Man, and Cybernetics, Part B. He also have several other associate editorialship positions. Okay, so with that very brief introduction, let's start with one of our panelists who would be giving a presentation for us. Professor Denise.
Thank you, Reza, and thank you for inviting me today. So for everyone who was here for the first speaker, for Duncan Watts, thinking about networked complex systems as a social scientist, right? Social systems are networked complex systems, even though most of you, I think about the technical side of the networked complex systems. And what I wanted to do is just quickly go through the way social scientists think about it, although obviously you just heard how social scientists think about the system, but just at a sort of a higher level in general. Right? So the same way that you think about thinking about the technical systems, the micro-level interactions of the agents, the characteristics of the agents, their choices, their behavior, the relationships between the agents produce macro-level outcomes, macro-level patterns. And those macro-level structures at the same time are not only an emergent property of those micro-level conditions or the characteristics of the agents, but those macro-level conditions can then also constrain the behavior, choices, actions, preferences of the agents at the micro level. And so this is a mini way to think about sociology or social science, the study of society. And so what social scientists think about is what is the link between the micro-level interactions and those macro-level dynamics, much the same way, and bringing together the macro, or bringing together the mathematical properties and those techniques to try to understand those relationships. But social science in general is thinking about then what are the social implications of those relationships, and that is precisely what Duncan was talking about for a variety of different kinds of outcomes. So for example, social networks, we might think about how the nature of the ties between individuals, how the structure of those networks, for example, influence the diffusion and influence of information on the individual actors. And Duncan obviously has done some of the premier work in that area. Other social scientists have looked at how social ties and social interactions at the individual level and the structure of those networks overall affect the eating behavior of the individuals in those networks and the spread of obesity over time in the US. So Nicholas Christakis, who is a physician and a sociologist at Harvard, has done some of the pioneering work looking at how the structure of the relationships between individuals actually influences the individual property, obviously, of obesity, and that it isn't just individual behavior, it's actually an outcome of social interaction. The creation and maintenance of social norms is much studied by social scientists who look at it and how the emergent properties of the network influence the creation of norms, sometimes norms that actually harm the participants in the group. So how individuals might actually reinforce behavior that ends up being negative for them. This could be a way you could look at the results that Duncan just showed on how individuals may end up reinforcing a norm to give less to the group, for example. I worked in my graduate work on some projects that look at, for example, the needle sharing patterns among injection drug users. And you can think about the dynamics at the individual level and how the structure of the networks among injection drug users and their patterns of use will influence the spread of HIV. So the diffusion of the epidemic across the country, across the world, can be understood in part by thinking about the networked complex system of the injection drug users. And of course, there are implications for how we want to reduce that risk, how we want to intervene to prevent that, that diffusion. I've also thought a little bit about physician referral networks, for example, and how, again, the diffusion of a new treatment, for example, the adoption of a new treatment is in part dependent on the structure of the networks. It's not just dependent on the evidence base and how good this treatment is or having the skills for it, those individual level characteristics, or even having the resources in the hospital. It depends on the structure of the social network between and among physicians that will influence the diffusion of that treatment. If it's an effective treatment, we want it to diffuse widely. If it's a costly treatment with questionable benefits, we don't want it to diffuse widely. And so there are implications for both quality of care outcomes as well as the cost of health care. So these are some of the ways that social scientists might approach and have approached studying the networked complex systems. But I think now, and some of the work I've been doing with the computer scientists here at Dartmouth and through the Institute for Security, Technology, and Society, is really trying to think about and understand the interaction between the complex networked system of the social system with the technical networked system, and what are the implications then of these two complex systems interacting. And just to give you some examples from my own work with colleagues here at Dartmouth, we've thought about Wikipedia. So here is both up, right? The technical system, I assume everyone is familiar with Wikipedia, right? It is an online encyclopedia to which anyone can contribute or change the information there. It is enabled by this complex technical system, the internet. It is known to have reliable information, which is surprising given the nature of the characteristics and behavior of the individual agents. They are not screened by expertise. You can be anonymous and contribute. Those kinds of conditions, typically, social scientists expect to have low quality outcomes. And yet, Wikipedia in general has high quality outcomes. And so thinking about the characteristics of the individual agents, you have two types of agents at its simplest level. People can be anonymous contributors, or they can be registered Wikipedians, members of the group who might have some commitment to the group itself. And our questions then are, just knowing this basic information about Wikipedia, what are the implications for the reliability of information? So you could think about this. This is not doing complex systems analysis, but that is an emergent property from this complex system that we analyze. And I think you should hopefully be able to see this. And so what we found in our study, this is joint work here with Professor Sean Smith in computer science, and actually Tim Williamson, who did this as part of his undergraduate degree in computer science here at Dartmouth. We selected a random sample of Wikipedia contributors, and we looked at the reliability of the information contributed by those anonymous contributors compared to the registered Wikipedians. When we just look overall at reliability, that's the middle line, and we don't see a variation, much change over time given the number of contributions that people make. So people who make only one contribution have about as high a reliability as the people who make many contributions, and you might have expected something different, like people's reliability to improve with the number of contributions. But we see something very different when we think about the characteristics of the types of contributors, in which anonymous contributors who contribute one time have very high quality. And even though we are controlling for the size of the contribution and the article size and that kind of thing, because one-time anonymous contributors usually contribute very little amount of information, and it's likely to be high quality, but even when we control for that difference, we see they have very high quality, but it declines with contributions, while the opposite is true for the registered Wikipedians. And there are some social science reasons to understand this kind of dynamic about contributions to the group and commitment to the group, et cetera. But this is really an emergent property that depends on some of the characteristics about the social expectations and conditions of the actors interacting in this technical system. A more important, I think, potential interaction between the complex social system and the technical system are the implications for privacy and security online that I know many people here and on this panel are also interested in. And what I'm going to do is just very briefly talk about a little pilot study we did that is suggestive of the issues with this interaction between the social and the technical. So we can think about the characteristics of the individual agents, that is the users like us online. oftentimes in online settings, we have very limited information about who our interaction partners are. We may have an email address, and we know how reliable that is as an identifier, right? We often have very limited information. And in fact, in some settings, we may only have information about the privacy settings of the other actor. And for example, some of the settings that we have imagined for the technical system and why we might only have privacy settings for information is, for example, if there's a secure online resource like a team wiki for a distributed work group who has never met each other, who works in different parts of the world, they may have more identifying information, but it's likely very limited. But they may know a little bit of information about the privacy settings of the other people in the group with them. Another possible technical system structure that will arise very soon is to the extent that we know sensor networks are being deployed to a much wider extent. For example, if there were sensors in this room that were going to maybe post information about what was being sensed, voice, maybe video, other kinds of information about what's going on in this room, one idea is that to determine whether that will be revealed or not, kept private or not, might be some way of trying to balance our individual privacy settings into a group privacy policy, right? How are we going to set that up? How are we going to make that work? And so what we might know, or what our devices might know, is the privacy settings of everyone else, in part to determine that. The question from a social scientist like me is, does that limited information that we might get from the technical system influence our interaction with the other parties in the group? For example, how likely they are to cooperate or not. This is a little different. Duncan's questions are about, will it influence how they behave because me knowing what you do? This is a slightly different question. Will I behave differently toward people who have different kinds of privacy settings? And so we have very limited pilot study data, but what we found is that in fact people do seem to infer trustworthiness from the privacy settings of others and change the way they interact with people. So people who have lower privacy settings, people are less likely to trust and therefore change the way they interact in the group, potentially making them be less likely to cooperate, which could mean contributing to the group good or could mean revealing a password, for example. Of course, that has important implications for the privacy and security of the technical system that doesn't have anything to do with the underlying technology for securing the system, but it means the social behavior can have implications for that technical behavior. So I think this kind of group and this kind of panel has the opportunity to really think about how these two kinds of complex systems can interact to produce emergent properties that neither one of us in our own groups, the social scientists just talking to each other about the social implications, and the technology experts talking to only each other about the security and privacy of the system, we might not get the best answer until we start talking to each other. So on that, I'll thank Reza for bringing the group together.
Okay, so what I'm going to talk about is from a slightly different perspective than what Duncan and Denise are talking about, is that, my particular goal is to look at how you model some of these social phenomena in order to explain the behaviors that we're seeing. Every day we go through in activities, watching groups of people doing things, we're trying to understand why they're making these particular decisions behind it. Now, I'm not going to go through a lot of these, but when we talk about the social networks, we can also talk about that it's the influences from organizations to nodes, such as some of the things Denise mentioned, that a group can actually have an impact on the individuals. And so what we are looking at is trying to get to the factors behind what kind of impacts they might be. So if you think about it, from the modelers or analyst's point of view in terms of what your challenges are, one of the things you run into, of course, is just you have a lot of data, you have a lot of possible insights that are always being generated by watching and observing the system going on. You have also, if you think about it, what's a social network? Well, what does a link mean? There's many, many different types of links that are going on. They could be friendship links, they could be financial responsibility links, they could be emotional links. And then you think about the question is that if we are seeing these connections being made and then how the behaviors among the participants in these connections, you want to ask the questions, the classic what, how, when, why, and whatever, all the other WH questions you can think of. But then you run into the issue that you always will have incomplete data. So part of the point of the modeling is that, hey, maybe my model can be an initial estimate of really what's going on here, and then by looking at the model itself, give at least some hypotheses about what's going on. So the other thing, though, is that we all well know is that these things change over time. So that gives us yet the other challenge is that just even having somebody tell you somebody or somebody give you a piece of information, that can actually change your decision-making patterns. Now, the thing what we've been focusing on in my group that I think is very interesting, of course, is culture again, which was brought up by both Duncan and Denise, and that, what are these elements of culture, and what does it mean to really try and model and capture that? And so, we can think in many terms that, our own experiences, our own backgrounds is a very major factor influencing how we make our decisions. So, this picture is just the top of the file. Is that if we just talk about a social network, you just can't analyze it or look at that network just sort of in isolation and analyze it in terms of changing. So, this sort of little graphic says that the culture that you have is what also drives those changes involved. And I think it's very neat that, when, I think it was Duncan that talked about people who couldn't figure out disagreements, that they were missing whether that people could identify if they're really in agreement or disagreement with somebody. These are also aspects of cultures that are embedded here. So again, from that point of view, it's this question of how do we as engineers and scientists help try and understand these sort of complex systems. I'm just going to talk briefly about an approach that we took, and this was we decided to take a look at the 2008 South Carolina Democratic primaries. This is joint work with Eugene Santos at UT El Paso, myself, John Wilkinson, who is a PhD student here, and Longpan at Virginia Tech. 2008 South Carolina, if people remember, that was the first of the primary elections where Obama really came onto the stage. All right? It wasn't really expected that Barack Obama was was a possible winner for South Carolina. So the only reason I just put up this map, this is actually a county map of South Carolina, shows some demographics of what were college towns, what were cities. And this was the final results of the South Carolina primaries, where based on each of these counties, the blue, I think, coloration shows that these are the counties that Barack Obama carried, and then I believe that the Clemson County way in the top northwest corner is what Edwards carried, and then what was in the far east was what Hillary Clinton carried. Why do I bring that up? Well, this is an interesting domain if you think about it, because it has all these elements of culture. So you can think about that all the different factors that help determine some of the behaviors are things such as, what is some of the ethnic compositions, even growth of, for example, the Hispanic population. I'm just going to flip through these quickly. I'm not going to, it's just to make a point of all the different elements that come into play. Even population change, population in terms of education, population and poverty, etc. Okay? But the whole point is that there are many of these going on. So these are things that make you pull out your hair if you want to try and capture all this, because the question ultimately you want to ask is that, what about opinion change? How does it spread over time? So here's the experiment that we were doing. All right. So we analyzed sort of the 4 months leading up to the election for the 2008 Democratic primaries. We felt this was a good scenario because there was certainly a large amount of data, there was a lot of connections and issues, and trying to figure out how people will vote. And let me just actually jump in a little bit. What we did was we took data from public news sources to try and determine what the events were. The events then were part of the modeling and how people change opinions. We also then sort of calibrated our system with the initial polls. All right, so these are all the public data. Now, what was this really modeling about? Well, our model looked at the counties themselves, the simulation of the individuals in the counties, the connections between them, geographic elements. Try and look at, you could imagine that as just one big social network, and then try and determine those behaviors involved. Now, I want to say this, and that's that last line on the slide, is that our goal, right? Our goal is not about predicting the election, but to analyze and try and explain why certain things in certain conditions happened on the elections. Now, one of the pieces here that we talk about, I said the word we want to explain and analyze. One of the foundations that we believe in is the whole notion of intent modeling, is that what is the intent of the person? So you can imagine that the intent are those major factors that are coming in that drives and changes their decisions or influences their decisions on their future actions. Now, just very quickly, don't worry about the eye chart. What we did was, if you think about it, every event that happens provides some sort of piece of knowledge, like I talked about before, that is influencing the person who's exposed to that knowledge. So for example, on November 27, 2007, the black ministers endorsed Hillary Clinton. So this would have an impact in voters' minds of those who were, for example, of the appropriate ethnic group, those who might have been of the appropriate religious persuasion, that this would then form a factor. Other things, for example, one big element that came out, of course, in the South Carolina primaries was the impression that Hillary Clinton had downplayed the, I'm sorry, was it Bill Clinton or Hillary Clinton? Sorry, I just drew a confusion. Mm-hmm. One of the Clintons, forgive me, downplayed the civil rights accomplishments of Martin Luther King. So that also had an impact as well. Other ones like, for example, Edwards visited his home county in South Carolina. The whole thing is that our whole goal is when we built the model, we were trying to do the simulation. Yeah, even though I said our goal is not to predict the voting, we want to make sure that we can calibrate that what we felt about the voting was looking close. So the top graph here was from our model, how sort of the trends and changes in the voting pattern versus the bottom one, which was an average of a whole series of polls that were taken over those time periods, okay? Now, the key, though, is that we wanted to try and see if our model can do the explanations. So here, the reason this slide is just called Obama explanation, because this is just one of our examples, is that why did certain trends change? So for example, one of the first ones was that in this case, it was thought about that, is Obama a candidate for change? The perception of that was why Obama could get that, at least that sort of trend that didn't have him be decreasing. Then you have other ones where it was felt like, Clinton was more electable, which is why you have the certain downward change. You have another one where the belief that the country wasn't ready for an African-American president. Then the other big one was along lines is why was that surge? The surge was changing over that Obama was more electable, that Obama had won the Iowa primary, and all these other factors involved. Now, just for you folks who are curious, in part of the explanations, our validation behind that is to also look at, all right, this is what our system generated in the major elements that influence people's decisions. And we looked at it in terms of compared to the political pundits or the analysts at that time, and they also came up with something similar. So again, here in the explanations, we're not going to go through that, but that's everything I basically says. And here, if you think about it, each of these elements here are play as beliefs of the individuals with respect to maybe their demographics, their history, and whatnot, in terms of making their final voter choice. So let me just wrap this up. The whole point we want to do is that we want to try and get our hands around this. Try and see if there was a principled way in building such a model like this, and go ahead and tackle a real-world problem such as the elections. The thing is, what we have to, of course, continue further on is that even though I said the word validate, I got to put the word validate in quotes. It's like, validate, we looked at the pundits, they seem to say the same thing we do, but we need, of course, push further and define, much more concrete validation of data, much more concrete ways of measuring things. We also need to do a better job of tying in some of the existing social and cognitive theories behind why people make these decisions. And the one thing that, even though I emphasized at the beginning that we didn't talk as much about is that network change, right? That's really one of our challenges. Why do networks change over time? How do they change over time? I actually really didn't say much about that here because we didn't have, first of all, we didn't have enough data to do that, but this is something that I think we need to move forward on. So the closing comment is that it's really about capturing that model, being able to explain and analyze it, and taking it from that point of view. Thank you.
Our next panelist is Professor David Kotz.
I took the unusual step today, I think, of not using PowerPoint. I'm usually the first to do it, and but today I decided to be different, I suppose. I'm also different in the sense that I suppose when I read the topic of the panel and saw complex network systems, I'm a computer scientist. I think of computer systems and of computer networks, and so I'll be talking about a little bit different kind of networks than what we've been discussing so far today. And my interest has been for many years in mobile devices, mobile computing systems. And of course, many of us, perhaps all of us in this room now carry cell phones, which are essentially mobile computers. And they're getting to be more and more pervasive, even here in Hanover, New Hampshire, where you can barely get a signal. And the thing that I find fascinating and interesting about the future directions and trends in this space is that the number and variety of these kinds of devices is increasing dramatically and very quickly. So of course there's cell phones and music players and gaming devices and home automation devices and healthcare devices, new ones being announced every day, new ones being adopted by people every day. I actually discovered by accident that I was carrying several of these in my pocket. So this is another cellular device. This is a MiFi. It's a bridge between the cellular network and the Wi-Fi network. And it has only one button and one light on it. It has no other user interface. It's a great device, by the way. And I brought a couple of other ones. I mean, here's another wireless device. It's not really a computing device, but this is my car key, right? That's networked. And here's another one. This is a wearable device that is an infrared network and a radio network. It's just a beacon, a location beacon that pings as I move around, and it can be picked up by sensors that are looking for this kind of location tracking device. And there are probably others can't remember that I've got with me, but I guess my point is that the number and diversity of these devices is increasing dramatically, and their size is getting smaller and smaller. And so this leads to complexity, of course. Right now, you might imagine that we have order one device, networked device per person. You have your laptop. Okay, so I have a laptop and a desktop and a cell phone and a MiFi and a car. Okay, so mine are getting close to order 10. But I think that will become common in the next few years. And it's not too hard to imagine that getting to order 100. If you start thinking about networked home automation devices, your light switches and your entertainment devices, your heating control systems and so forth will also be networked. They're talking to each other, perhaps today over proprietary networks, but tomorrow over IP networks. I'm interested increasingly in healthcare, actually working with Denise on healthcare problems, and I'm starting to see an increasingly interesting variety of sensors, physiological sensors that measure ECG or EEG, pulse, respiration, activities of daily living, and so forth that are wearable or even embeddable. Pacemakers now are networked, not on the internet, but they do have a radio or magnetic interface that can communicate over a very short range so that the physician can query the pacemaker's parameters and history of actions without re-entering your heart. Or for that matter, change the parameters. And one of the things that I find fascinating about that is some work at the University of Massachusetts by a colleague, Kevin Fu, who his group discovered that they could hack people's pacemakers. So this gets into the security issues and the privacy issues that I'll come to later. So he was able to read at short range by standing next to somebody who had a pacemaker. Well, they didn't do this on a live person, but their simulations, okay, so here's a digression. They actually put a pacemaker device under a slab of bacon and figured that that was kind of comparable to being embedded in a human body, and then did their experiments. But they could read out the patient's name and age and medical ID number and pacemaker parameters, and they could change those. And pacemakers actually have a sort of a debug mode that allow you to trigger cardiac arrest, because when physicians implant them, one of the first things they do is trigger a cardiac arrest and see if the pacemaker does its job. And so this is kind of scary. So your heart could be hacked. So the number of network devices is dramatically increasing, or will be, and the size is getting smaller, so they're harder and harder to find. So I think that one of the things that could be interesting is that you may not realize actually how many network devices you have. How are you going to manage those? So it's hard enough for most people today to manage their laptop, to keep it configured properly, apply all the patches from Microsoft or Apple or what have you, make sure that they're behaving the way they want them to behave and are not vulnerable to misbehavior from network-based attackers. The location of these devices leads to complexity as well. So today, most people have their laptop in their backpack or their desktop on their desk, and you kind of know where they are. But as I said, as they get smaller and as they get embedded, it becomes more difficult to know where they are and to configure them. So I remember a story from talking to some of the Thayer School network engineers a few years ago when they were working on their Wi-Fi network. They discovered a rogue access point, an unauthorized access point somewhere in Cummings. And they spent a week or two tracking it down and eventually discovered it was in that projector up there. That apparently, unbeknownst to them, the projectors came with a Wi-Fi interface so that the network, the projector engineers could interact with it and configure it. If your home starts having network devices in all the electronics in the house, the heating system, the cooling system, et cetera, finding and configuring these things could be difficult. They're going to be very diverse. So I mentioned phones and laptops and gaming devices and health devices. The number of devices that are on the network, and the variety of devices on the network is going to increase, and their purposes will become more diverse. And how do you manage that complexity that comes from the diversity of platforms, operating systems, purposes, interfaces, et cetera? And ultimately, I'm a privacy and security person now, and I'm interested in the risks of this complexity. Complexity of systems generally means that you have interesting risks. So, if nothing else, there's this cognitive overload. If I now have to somehow remember and keep track of and maintain and manage hundreds of devices of my own, that's complicated, right? It's hard to keep track of these things and to configure them. But security and privacy are the ones I'm really concerned about. So these devices, especially the small ones that have almost no interface, have to discover each other, configure each other, and rediscover each other. So as I walk down the street, my phone is looking for my home network and saying, where's that Kotz home network? Is that Kotz Wi-Fi network here? It's actually advertising, if I was that careless, my home network name and therefore something about me. Once you get these devices talking to each other, that usually means introducing them in a way that allows them to trust each other, not in a social sense, but in a computer security sense. And that means that if one of them is weak and becomes attacked, that becomes an infection point or an attack point that could compromise others as well. I sort of think about computer security, most of us do, in terms of internets and laptops and desktops and servers, but if my home is a network system, my home might become sick with a computer virus, and my heating system or cooling system might not work. In fact, you can imagine new forms of blackmail. Pay up, or I'm going to crash your heating system on a very cold New Hampshire night. Or phishing, so people talk about augmented reality. These wearable glasses that provide you a view of the physical world, but overlay it with an augmented virtual world. So now the phisher has a new tool, if they can get in through the network to this augmentation, to change the way you perceive the world, and perhaps socially engineer your behavior in a way that's beneficial to the phisher.
I got a rose-colored glasses.
Rose-colored, no, very good, thank you. I'm sorry, I didn't think about that. So there are lots of privacy risks with these kinds of systems as well. Of course, if I lose these data, or if people steal these devices, the data goes with them, and the keys, the crypto keys that are in there, presumably providing encryption support for my protocols, also go, and they therefore might be able to get back into my other networks. Even if you encrypt all the traffic, which is expensive on small battery-powered devices, they can still leak information about you. So there's some interesting traffic analysis studies where people have discovered that even in a VPN connection, if you're watching the traffic on a virtual private network, encrypted traffic, you can discover that the traffic is carrying voice, for example. And even better, what I thought was even more interesting, they could tell that they were speaking Spanish as opposed to English. And this is encrypted traffic that you shouldn't even know how many flows there are, let alone what those flows are carrying. Of course, a lot of these will require back-end support in the infrastructure, cloud services, as I guess is the buzzword these days. And those are going to collect a lot of this information and make use of it for all kinds of purposes that we find beneficial. But of course, those then become a privacy concern as well. What are places like Yahoo and Google going to do with our data? And how secure is that data against misuse from other parties as well? Of course, I talked about sensors as well, health sensors or activity sensors. If the information that's being collected and shared by these talks about where I am and what I'm doing and who I'm near, that is potentially much more private than the kinds of information that I do on my laptop today, and I might be even more concerned about its safety. Even if it's been anonymized, we increasingly find that you can mine anonymized data for patterns, and that sometimes you can link those patterns together. So one of my grad students is starting a study right now where he's trying to find out if there are people on campus like me who carry multiple Wi-Fi devices, even if it's been anonymized so it doesn't say my name, if it's the same set of 3 devices that are seen together in different places, you can then link these devices to each other, this location history to a location history, and maybe recognize who is likely to be that person. So anyway, complex systems, network systems are becoming increasingly complex, and that complexity leads to challenges for management, security, and privacy. Thank you.
Okay, at this point, I'd like to open the floor to questions that you have for any of the panelists. Yes.
For Denise, you noted that in the Wikipedia model where you have 2 different social networks, effectively, people who are anonymous versus people who are registered. What was the behavior you saw as people moved from one network to another? Right? Did they sort of pick up where they'd left off in terms of their number of edits, or did they start back at 0 effectively?
In our data, they would have started back at 0. And there is some, and in fact, we haven't tracked that, the people who might go back and forth. Partly we can't because we don't know who the anonymous people are. Actually, we do have potentially a little bit of identifying information, so we may be able to even track that. But that's some of the idea that why the registered Wikipedians, for example, have such low quality at low numbers of contributions. If you might start with a particular ID or a registered name and your material is getting changed all the time, you might decide to abandon that name. And so we can't actually, that's a different question than what you asked, but we can't control for that in our data, but that might help explain why they're so low. And you can imagine the alternative, which is what you said. They want to keep contributing. They don't want that ID anymore, and they just become anonymous and contribute anonymously, and they might be at the low quality, high number of contributions for the anonymous. So it's what you imply, but we can't actually see that in the data, people moving.
Question for Dr. Kotz relating to security of day-to-day technology and infrastructure technology. So it seems like in the case of these crackable pacemakers or dial voting machines that could be hacked into from the web, there's some point at which you need to say to the designers, you're doing it wrong. Do you see a way to make security either enforced in design in matters of public safety, or enough of a part of public and designer consciousness that they police themselves and design safe equipment that doesn't have hidden
That's a good question. That's a very hard question, I think. I think the first challenge is awareness, as you imply, is to make sure that engineers and designers are more aware of the potential risks that come from security-type attacks. I think engineers for years have understood reliability and various failure modes, and only recently, I think, are the kinds of people who build these embedded systems beginning to realize adversarial type attacks and network-based attacks. People who built pacemakers, I'm sure that was the last thing on their mind, and I think the work that was done that I mentioned is a step in raising that awareness. As far as enforcing it, I think that's, that probably is very dependent on the particular product type in terms of whether that makes sense. The part of the challenge, I think, is that consumers, the people who buy these products generally, I think this is well known at least on software systems, are looking at features. That's what they want, and they don't necessarily realize that they also want and need the security features. And so it costs a lot to design in and build in secure mechanisms, and so the vendors, sell what people ask for. So to some extent, we get what we want, or what we're asking for. So it's also a question of educating the buyers that they need to think about security issues as well, and privacy.
Fascinating panel. Thank you so much for putting this together. It brings together a few of my favorite issues, security and complexity. But thinking about this, and I have put a little bit of fun into this, it seems like from the technical side and the social side, the drivers are different. On the technical side, things are becoming extremely complex, which I think Dave so rightly linked to risk when it comes to privacy and security. But manufacturers are trying extremely hard to hide that complexity. On the social side, all these devices are enabling much more complex social structures, but it's also hiding the risks there. So when I was just at a conference earlier, and awareness is a huge topic. And so I think one of the challenges is how do you actually, and this gets to the question that was just addressed, how would you use kind of the social complexity of social networks to actually make people more aware of the privacy and security risks that they face while using these devices, while at the same time reducing the complexity that people see when they actually build and design these devices. So it's a tension here. Was there a question?
There was a question, but go ahead.
Yeah, I mean, you're right about that, and I think obviously the flow of information was partly a theme, in Duncan's talk and Eugene's, and how that can flow through the social network. So to the extent that information and influence, potentially, on people's choices can come through the social network, and that we think that could be nudged in ways that are more secure or helping them maintain privacy in the ways that they want, that's, I think, can be used, or I don't know how to do it yet, but I think that's the right path to think about it. The only...
Is that a technical thing, or is that a social thing? What do you think is that?
Well, it's the combination, right? I mean, if it has to be part of the technical design that it's available for someone to put in their Facebook page, or it's sort of like what I think Duncan showed in some of their work. If you have the ranking of the song, that influences people's behavior. And it's the same kind of idea. I don't know what it is. Is it the ranking? Is it the piece of information about security and privacy that might then influence people's behavior? But that's only one. My caution about that is that that's only one element of security and privacy. So you might be able to tell me to avoid a particular network because you or your devices or something found out that that was less secure, or a pathway into that network was less secure. And if you share that with your network, we then have that information and might be able to change our behavior to avoid that network or whatever, that device, well, you can imagine what it is. But if I can't avoid that network, for example, to do something I want to do, to communicate with my bank, I can't think necessarily of all the scenarios, but so having the information might tell me something, but if I still need to get from here to here and the only pathway is this unsecure link, I guess I do have a choice, engage with the unsecure link or not, but I don't have a way to avoid it. So that's on the technical side more, I think, is having more tools potentially to only communicate in the secure way. If I'm not explaining this clearly, but if information is all I need to behave more securely or more privately, then the social network and having those tools is a great way to do it. I don't think security and privacy is just about knowing this one is secure and that one's not. At the moment, there's too many ways that the system itself is not secure. So more information might be better, but if I still can't avoid the unsecure pathway, then that information isn't all that helpful. I hope that was sort of clear.
I'd just like to add a little more to what Denise just said, and I completely, one of the ways you can look at it also is this, is that you also mentioned one of the things that you were just involved in is awareness. And so there's also the aspects of being able to train the personnel who are, for example, one of the conferences I got involved in was on resilient control systems, which their whole focus was really about how do we, for example, secure our national power grid systems? How do we secure all these things? There's always human operators involved. And part of that is that just something a human operator, as say, for example, part of their social network can go to Facebook and do something, will have a risk issue that's coming back. So that also ties in from both the technical side, the social side, plus also then the training side of accounting for that and awareness. And these are really big open challenge problems at this point.
So one question that I find sort of fascinating, I know the answer is you know, how much do people really care about privacy? And if you ask people if they care about privacy, they say, yes, I care about privacy, you know. But then if you look at what they do, people are, you know, sort of flagrantly irresponsible about, you know, posting all kinds of information about themselves in the most public way possible. And so then you have to ask the question, well, do they sort of say one thing and do another? Are they revealing preferences that they through their behavior that are different systematically from what they say to you know, their congressman? Or is it they just don't understand, right? So, you know, an interesting case study is cookies, right? So, cookies on your web browser, you know, were not invented to violate people's privacy. They were invented because it's massively more convenient to surf the web if your web browser remembers who you are and tells the server, so you don't have to. I mean, if you do what I do actually, which is, you know, periodically delete all my cookies, you know, it's a real pain because then you have to re-log back into everything and nothing recognizes you anymore. And so you realize, you know, when you do that, you realize, you know, how many sites are sort of recording little bits of information about you. So it's meant to be convenient, and it is. And so you might say, well, people are happy with that. They're getting something for this trade-off. But then you might say, well, you know, they don't actually know that they're making this trade-off because this is all sort of happening semi-automatically in the background, and most people don't even ever change their homepage settings on their browser that comes like as the default installed on their computer when they buy it. So like those people are clearly don't understand what's going on with cookies. And so, you know, maybe if they just had this explained to them clearly, then they would react differently. You can ask the same thing about being shown ads. You know, do people do they like relevant ads? You know, would they rather no information was kept about them and they get ads that they don't find useful? You can ask people these questions, but actually you can't really believe the answers because people are sort of all over the place and they contradict themselves. And so I think that there's just, you know, it's not just a policy matter here. I mean, I think there's a lot of policy effort and thought going into, you know, what should be retained and how long should things be anonymized for and when should we rotate the keys and all this kind of technical discussion. But there's sort of a much more fundamental scientific question about, you know, like, we really don't understand, you know, what people actually really want and how much of it is ignorance and how much of it is just sort of, they hadn't really thought about it. And I think that there's a lot of interesting work that should be done there that could inform the policy debate. And it's curious that work hasn't really been, has not really been done. Even though policy question is getting a lot of attention, but no one's actually doing the science.
Could I just have one follow-up to that? Because I think that's exactly right, and Scott and I have talked about this many times, right? The issue, but it's not just the difference between revealed preference and the sort of stated preference, I think. There's also the lack of the alternative choice, and that was what I was trying to say. So for example, the grocery, it's like the cookie example, but the grocery card that keeps track of my purchases so that it tells me about the reductions that I get on the purchases I've made before, reveals lots of information about me, at least to my grocery chain or whatever. And, but I might decide that trade-off is worth it. Maybe some people don't realize how much information is being gathered. That's awareness. But lots of people do and say, I think the potential savings I might get from that are worth my grocery store knowing this information about me. Now, if I had a choice to get those savings, but without revealing or having my grocery chain keep all of that information, I might be willing to make that choice. And I might even be willing to pay a little more to, you know what I mean? So we typically, the choice set, especially when we're talking about policy, because the technology doesn't enable all of those preferences, we're not trading off all of those.
So let me ask you a question. So let's say I tell you that that Gmail, if you use Gmail, Google will keep your personal information non-anonymized in their servers for 13 months. And if you switch to Yahoo Mail, then you know, as of the end of this year, your personal data will be anonymized after 90 days, right? So this is a big deal, right? Like, this is like, you wouldn't believe how much, you know, effort has gone into this this particular change in policy, and it has to do with mostly the European Union A29 legislation. So the question is anybody going to switch from Gmail to Yahoo Mail because they think, oh, well, 90 days, right? That's, you know, that's big. I mean, what is it? Is it big? Is it, I mean, I didn't even know how to quantify that. I mean, you know, like, so if you...
You'll have the data, you can tell us.
Even if you give people this information, I don't even know how do you put in you know, like, so take the shopping cart example. Like, okay, we're going to collect this information, but we're going to delete it after a certain period of time, but we're going to give you less of a discount, right, than if we keep it forever, right? I think, I don't know how anybody makes those decisions or anybody makes decisions about on the behalf of other people making those decisions. But the other point I think where it gets extremely tricky is related to David's point earlier, that there's a lot of information that on its own you would be happy to make public. But when all of this stuff gets put together in a way and then is presented to you, you get these sort of freak out moments where you sort of realize, you know, I had this experience a while ago. There was a startup company called Spokio that you would just sort of suck in your email address book and then just go around and hit every public API they could find for you know, for Facebook, for Flickr, for Friendster, for FriendFeed, for Amazon. And, you know, my email address book is a real sort of, you know, kind of laundry list of, you know, everybody who's ever emailed me. You know, so somebody who sent me an email once 10 years ago is in my address book. and all of a sudden I'm looking at their Amazon wish list. And, you know, they have these sort of books on there that, you know, I sort of feel like I'm learning something rather personal about this person who knows presumably that Amazon wish lists are public and sees some value in having that information up there. But didn't think about the fact that I might be looking at that sort of several years later because their email address happened to be in my contact list, and there's this company that got created that didn't exist back when we had this email exchange. So I think that when you start putting together these different sets of information where each individually, someone, even if you give them perfect information about the trade-off that they're making, you suddenly put these things together and they're like, oh, that's not what I meant, right? So it's like the young girl who had the argument with her mother about her blog, and because her mom started, you know, they had the usual sort of teenage mother problem of communication, and so her mom starts reading her blog to find out what she's doing. And then she, you know, she's telling the whole world about what she's doing and her love life and everything, and she finds out that her mom is reading her blog, and she's like, Mom, you can't read that, it's private. So we just have these very sort of unclear notions about it. So very, you know, I think it's a lot more complicated than we let on.
Any other questions? Yes, Pat.
As a healthcare worker, this is for Denise. I'm just curious why you chose HIV for your study rather than something like hepatitis, which is more prevalent.
Yeah, no, we did look at hepatitis too, but yeah, we were looking at all kinds of infectious disease that could be spread through injection drug users, and hepatitis and TB as well, so.
Yes.
I have a question, I guess it's for the whole panel, but it's in reference to something that Duncan mentioned about how people's professed positions on privacy don't necessarily correspond with their actions. And I'm really rather ignorant on the question I'm going to ask. The question is, has there been any studies done to look at if there is a big correspondence between the size of a group that they're revealing information to with regard to their preference towards privacy? Because my impression is that as the group gets larger, as it gets more public, people might tend to think, I've got some anonymity just because of numbers, and they might be more inclined to release private information to large groups of people rather than to smaller groups. Yeah, exactly. I mean, it's almost reinforced by your anecdote that you just mentioned. Is anybody aware that that's been studied?
I don't know. Good question.
There is some evidence from people who participate in these online chat groups, like support groups around diseases in particular. And it's not directly to your question, but some of those people talk about participating in them and revealing lots of very personal information, and that they do it because even though they know they may or may not be anonymous, it's with that feeling, like you just said, that I don't really know any of these people, and therefore it's okay. In that sort of reverse, it's not exactly the same, but.
Dr. Kotz's comment, you were talking about the increased complexity of carrying around so many different devices. Like, you know, there's also the forces that try to amalgamate these devices so you would sort of keep the complexity down to the degree. Maybe you can only wear one or two. Like, before you had your Walkman and your phone and everything, now that's together in one unit.
Yeah, that's a good point. So there is certainly some consolidation, especially into the smartphone type device. And I think I've heard of some people who even have abandoned their computer because they just use their smartphone. I guess what I'm thinking about is the increasing number of small, very special purpose sensing devices. At least that's where I've been thinking these days, is in health sensing devices, activity sensing devices, that wouldn't necessarily work if they were inside your cell phone, for example, because they physically need to be on your wrist or, you know, around your neck or something in order to do their job. And then some of the other somewhat futuristic interfaces, earpieces or eyewear that are networked and computerized, again, may need to be there because that's where your sensors are in order to receive that input. And so Both will be happening, but I think because of the nature of certain kinds of devices, we will be seeing more and more of them nonetheless. Good question.
Anyone else? Okay, so let's adjourn our panel discussion, and there will be a lunch break, and we come back for the afternoon session. Thank you very much.